I'm out of the office today, so no update of the commodity markets. However, we do have the latest edition of the Illinois Nutrient Loss Reduction podcast.
Todd Gleason services are made available to WILL by University of Illinois Extension.
This is episode 81 of the Illinois Nutrient Loss Reduction podcast. I'm University of Illinois Extension's Todd Gleason. Today, we'll explore the role of the soil microbiome in reducing nutrient loss with a couple of folks from Waypoint Analytics. We'll learn about it as we explore the biome and how it interacts with the ecology of the soil. Let's start with Elizabeth French. She goes by Lizzie. Hi, Lizzie. Thank you for being with us. Tell me about yourself, please.
Yep, I'm Dr. Lizzie French. I currently live in Laramie, Wyoming, but I was spent a good chunk of my adult life in the Midwest. I got a biology degree at Indiana Wesleyan and then went to grad school at Purdue in the botany plant pathology department. I started working on projects with tomato pathogens, but then I got really interested in all the other bugs that were out there in the soil and really ended up focusing more on just the soil microbiome as a whole, how it interacts with the plants and how that ends up impacting plant health and soil health. And I liked it so much, I stuck around a couple more years and did a postdoc in a different lab at Purdue, and then ended up moving into the industry, worked with Nutrien for a few years on soil biology and how we can use it to make agronomic decisions, and then moved over to Waypoint about a year and a half ago now, and have been loving it, really enjoying the work that I've been able to do with them, looking at soil microbes and how we can help make agronomic decisions, understanding, having that fuller understanding of what's going on in the soil.
Lizzie, on that point, tell me about Waypoint Analytical. What is this organization?
Yeah, Waypoint Analytical, we are one of the largest ag soil testing networks in North America. We've got 7 different ag labs across the U.S., and we run probably 2 million plus soil samples in a year. But we also offer, tissue testing, water testing, manure, fertilizer, pathology testing, kind of disease diagnostics, nematodes, and now soil biology testing as well, for looking at more of the good guys in the soil, not just the pathogenic organisms.
We're here today to talk about the soil microbiome. Can you tell me what that is and why it's important?
So the soil microbiome is everything, all the living organisms you can't see in your soil, right? So you've got bacteria, you have fungi, you have viruses, protists, nematodes. There's, thousands of different species of organisms. And, if you pick up just a spoonful of soil, there's going to be billions and billions of these tiny microscopic organisms living in your soil, making up that soil ecosystem and doing a lot of really important jobs in the soil that we don't always think about just because we can't see these organisms. They're really important for nutrient cycling, mineralization of nutrients, breaking down residues, building up soil structure, all really important things that we need to happen in our soils both from a production standpoint and a conservation standpoint, right?
Lizzie, this is about the biology, the mechanics of the soil, really the ecology of the soil itself and how it works together. What do you think creates a healthy soil across the Corn Belt?
Really, those 3 components together, right? You need to have the soil structure that allows you to have good air infiltration, good water infiltration. That interacts, the soil biology plays a role in that, where you've got, microbes producing these sticky glues that help kind of build that soil structure. You need the chemistry, you have to be able to grow a crop. That's what soil health is in production agriculture, right? You got to be able to grow a crop, and you want your grandkids to be able to grow a crop too, right? So you need to have the chemistry there to be able to grow that crop. And then, yeah, like I said, the biology piece interacts with all of that. So you need to have a healthy, thriving community of microbes that are able to cycle those nutrients into available forms that are helping to build that soil structure. And all of those things affect each other. So they kind of, you can't really pull them apart to understand them. You have to look at them as a whole to be able to really get an idea of the whole system. And so really, when you're talking about the Midwest, corn and soy, having, sufficient levels of the nutrients that you need to build those crops, having solid soil structure, and then having high levels of soil biology that are able to then, make those nutrients available, keep that soil structure where it needs to be.
Well, get to making the nutrients available or keeping them in place, probably both, actually. But how is it that you measure a microbiome? What happens? And are there good things and bad things about it?
Yes. So there are lots of ways to measure. The thing most people are probably familiar with is something like the Haney test, where you're getting a respiration metric. That is really kind of a 40,000-foot view of how much overall microbial activity do I have? Are they living and breathing? And that is a great high level metric. It doesn't tell you specifically what those microbes are doing and what they're capable of doing in your soil. What we've done with our test is we're looking at the DNA of the microbes in the soil. So you can think about, when you do a nutrient extraction, you have a specific process where you're separating out those nutrients, and then you're able to kind of analyze them on an instrument. We're doing the same thing, but we are finding the microbes in the soil, taking their DNA, and then we're able to specifically look at that DNA and say, okay, how many of you are nitrogen fixers? How many of these microbes in the soil can solubilize phosphorus? How many of you are mycorrhizal fungi that are going to help bring, essentially extend the root system and help that crop acquire more nutrients? So that's what we're really able to answer using that DNA analysis, is kind of who is it that's there and what are those microbes actually capable of doing in the soil.
On the microbiomes, are they capable of keeping nutrients, particularly nitrogen, phosphorus, in place? And if that is true, do they lock them in place so that they're not usable by the plant as well?
That's a great question. So, microbes need nitrogen and phosphorus too for their survival, right? So one of the ways that they help to keep it in the soil, well, there's two ways. So we'll talk about the first one. The first one, they keep it in their biomass. So as part of their body, they're keeping nitrogen and phosphorus. When those microbes are growing, yes, they do temporarily lock up those nutrients so that they're not available. But microbes have much faster life cycles than we do or that plants do, right? So that, within a short amount of time, days, weeks amount of time, that those nutrients that have been kind of vacuumed up into the microbial biomass become available again as they go through their life cycle. You have other organisms in the soil like protists that are kind of tiny little lions keeping the population of the antelope in check on the soil savanna, right? So they're able to go out and eat those bacteria, then make that nitrogen available again for the crop. So that's the first mechanism that they can use to keep nutrients in the soil. The second one is, which most people are probably more familiar with, is through building up organic matter. So that microbial activity, a lot of that microbial biomass, those dead microbes, become part of the organic matter. Those microbes are important and they break down residues. They keep that carbon in the soil. A lot of those nutrients are kind of locked up into that carbon. And so the soil organic matter, we really want it to be dynamic, active. You're building up new organic matter as you're mineralizing some to be able to make new nutrients available. So it's this cycle that microbial activity keeps going, where it's able to then retain those nutrients in the organic matter, make them available again for the crop.
That's Lizzie French. She's a soil biology manager at Waypoint Analytics. You're listening, of course, to the Illinois Nutrient Loss Reduction podcast. So, Lizzie, you're maintaining that it's important to understand how the soil biology interacts with, I guess, the fertilizer management. I think that's right.
Yep.
So can you improve the biology to manage that fertilizer?
Mm-hmm.
And how do you do it?
Yes.
What are the biggest opportunities, you think?
Mm-hmm. Yeah. So from a big picture perspective, right? Just any practices you can implement. This part is I would say it maybe gets rebranded every 10 years or so, but it's it's the same the same principles. You can boil it down to, your microbes need food and they need housing. And if you think of that, from a soil health perspective, that's protecting your soil structure, so minimizing tillage as much as possible. That's going to prevent you from breaking up all of those nice fungal networks that spread out throughout the soil and help your crop get to nutrients. And it's going to help, protect the soil structure, protect the housing for those bacteria as well.
I'm going to break in here for just a moment because tomorrow on this program, you'll hear a different podcast, the Weather Realness podcast, and they too will talk about soil structure, but in terms of dust storms and the importance of that soil structure and tillage to dust storms. Now, let's continue with the Illinois Nutrient Loss Reduction podcast here on Illinois Public Media's Closing Market Report.
And then you need to feed them, right? And whether that is through organic inputs like manures, compost, all of those things provide carbon to the soil for those microbes to live. Cover crops, just keeping a living root in the soil for a longer period of the year, where you're able to then feed that soil biology longer. All of those practices are going to build up those populations of microbes overall, and help you do more with the fertilizer that you're adding, because you're able to then, soak up that fertility into that microbial biomass that you're feeding. You're able to, you've got populations of solubilizing organisms and mineralizing organisms that are going to help, if those, say, phosphorus is getting tied up in your soil, you have that microbial activity that can help kind of bring it back into solution, versus, if you have lower levels of biological activity, that is, you'll need to apply more fertility to get the same result in your crop.
How important, Lizzie, are conservation practices in this soil biome, in this whole ecology of the soil and its health? You mentioned cover crops. I'd also like to know about kind of reduced tillage kinds of things, maybe waterways, the kinds of things that move water through and out of the soil. It could be even tile. You tell me what's important.
Yeah, so all of the above, I would say. The tillage, again, you don't see huge increases in soil biology as a result of reducing tillage, but it maintains what you have. You don't end up losing. And then adding in other practices like cover crops or application of organic inputs is going to build that soil biology. Waterways is an interesting one. Like I mentioned, I live in Wyoming, so we have the opposite problem of not enough water to keep our microbes and our crops happy. But yes, in Illinois, in the Midwest, where you have too much water sometimes and you need that tile drainage, that's actually a really important component of managing, a part of the soil microbiome, a part of that nitrogen cycle that leads to nitrogen losses, right? So nitrification, denitrification, those are both processes that happen entirely because of microbial activity. So you have the microbes that are taking that ammonia, converting it to nitrate. If you have a lot of rainfall, that nitrate can end up leaving through your waterway. You could end up getting denitrified by another group of organisms that are going to take that and convert it back into air, essentially. And so you've completely lost your nitrogen out of your soil that way. And those are all microbes that, you can manage through tile drainage, through practice, like applying a nitrification inhibitor on your nitrogen, splitting your nitrogen application so that there's not so much food for the microbes to then go chew up and get rid of at one time. There's lots of, things that you can think about from a nitrogen management perspective, especially when you can see one of these reports and see, oh, I have a really high potential to lose nitrogen, given the right environmental conditions. So I need to think about how I'm going to be protecting that nitrogen investment that I'm making on that field.
I do want to narrow this down a bit. So we could talk about the Corn Belt from western Illinois up through parts of Iowa, even into Minnesota. There's a large portion of that part of the Corn Belt which has similar soils, relatively speaking. How should maybe they manage their soil biome, do you think?
Sure. Yeah. I mean, this is, I would say this is always a tougher question, right? It's much easier to answer this question for, like, say, the South Plains of Texas, because, then really the soil there needs all the help it can get. Whereas, in the area you just mentioned, Illinois to Minnesota tend to have, those really nice, like, high organic matter, really good soils. So in my mind, and we typically see, when we look at those soils, relatively high levels of overall soil biology, even in, conventionally managed fields, just because you've got a lot of food there for your microbes. If you've got, 4 or 5% organic matter, you're going to have a lot of biological activity. And so I would, in those cases, definitely the conservation piece is important, because if you're not keeping that soil where it is, you're not going to have that microbial activity and good, healthy soil forever if you're not doing what you can to conserve it.
When we talk about the soil biology and the interaction and fertilizer management, as we've been doing some, how can you or a producer improve the biology to reduce fertilizer needs?
Yeah, again, so improving your soil biology in terms of specifically for nutrient cycling, it's still the similar practices. Those microbes are there. They might just not be at the level that you need them to be able to provide those benefits. And so implementing those conservation and soil health practices is going to help build up those levels. If you have, a soil biology test in hand and it's telling you that you already have high, good levels of soil biology, then that's also a point for you to trigger to think about, if I have decent levels of organic matter, I have high levels of soil biology, maybe I want to consider dialing back that nitrogen fertility a little bit, because I can pretty confidently say that you will not see it. You're likely not going to see a yield loss if you have that organic matter to mineralize, you have that soil biology, you're probably gonna, and I hate to make a hard and fast recommendation for how much to dial back, just because that does depend, heavily on how much rain you're getting, things like that. But that is definitely something to take into consideration when you're thinking about fertility, especially in the environment we're in with how the cost of fertility at the moment. This type of information can help you feel more confident about your decision to dial back on fertility if you have that capability to provide provide those nutrients from your soil and from your microbial activity.
What is it that you would like to leave with farmers? What kinds of things should they understand about the soil biome, the tests that you provide at Waypoint, how they might deploy it?
I would start with that, whether you've realized it or not, you've been farming your microbes this whole time. And, they've always been a part of the agricultural system, whether we recognize what they were doing or we didn't. And they're a huge component, and it's a big blind spot if you don't know where you're at as a system in terms of your levels of soil biology. So, I would encourage folks to just to take a look, try, just one or two samples across a field that's got maybe some variability in yields, where you can maybe try to understand, hey, is this low yielding area on my field that maybe is normally on a high yielding field? Is that a biological limitation, or is there something else going on there that that you might be able to identify with this type of testing, and just be able to think through better how to use the fertilizer you're applying most efficiently when you have all of the information available about your field.
Anything I didn't ask that I should have, or any other final comments?
Oh, the last thing I remembered, we talked a lot about conservation practices and soil health. The other big thing that we did not talk about from the soil biology perspective was pH. If your soil is very acidic, your soil health practices are not, like, they might help a little bit, but you're still gonna be limited by that pH in terms of your biological activity. That is one of the biggest drivers of soil biology in the soil. And so if your soil has become acidified over time, that's your first step. You need to manage that first, and then you can work on the other components to build up soil health.
Lizzie French is a soil biology manager. She works for Waypoint Analytical and joined us for the Illinois Nutrient Loss Reduction podcast. You may find that on our website at willag.org, willag.org, under the podcast tab, or just search it out by name, Illinois Nutrient Loss Reduction Podcast, and sign up and listen to it each and every month of the year. You're listening to the Closing Market Report from Illinois Public Media on this Monday afternoon. Be sure to stay with us tomorrow. We'll hear from another podcast. The Weather Realness podcast will take up the dust storms that have become more prevalent in Illinois over the past several years. We'll be joined by Trent Ford, state climatologist from the Illinois State Water Survey. We'll discuss the dust storms, the climate behind them, and the reasons, really, behind what's taking place in the state of Illinois. You want to make sure to tune in tomorrow afternoon for the Closing Market Report, when we'll have a special edition of the program from the Weather Realness podcast. In the mean space, you can always find our programming online at willag.org, willag.org, where each and every day the agricultural economist, the animal scientist, and the crop scientist right here on the Urbana-Champaign campus of the U of I post a brand new article to the website. You can also listen to, of course, to the Closing Market Report and Commodity Week directly from the website at willag.org. That's willag.org. I'm Extension's Todd Gleason.